Consider a sample with 5 scores and a variance of 20. If you were informed that these scores make up a population instead of a sample, the variance would be equal to which of the following values? Will it be 15, 16, 25, or 100? Okay, so in this case, we have to have a look at the formula for variance and how that differs between a sample and a population. So, when I'm dealing with a sample, my variance is calculated this way. It's the sum of squares over little n minus 1. And we know that this resulted in the value 20. If, on the other hand, I was dealing with a population, my variance is also the sum of squares, but now it's over the sample size, or sorry, it's over just the population size. I don't subtract 1. And we want to know, what is this one going to be equals to? Well, to work this out, we're going to need to put in our value of n equals to 5. So it's 5 minus 1. That's how we get 20. The sum of squares, 5 minus 1, sum of squares is divided by 4. That gives us 20. So in essence, we're looking to find out what divided by 4 gives us 20. If you want to isolate something in a formula, you can do this by going through 2 steps. The first step is to take anything that you don't want to see in a certain spot in the formula. So for example, I don't want to be dividing by 4. I just want to have the sum of squares equals to some value, not being divided by 4. So if you want to undo anything you see in a formula, just do the opposite. If I'm dividing by 4, multiply by 4. But the second step is you have to do the same thing to both sides. These ones cancel, and we're left with the sum of squares is 20 times 4. That is 80. How is this going to help us? Well, now we can put this into the formula over here, and if we were to find out that this was actually a population, so if we were to find out that we do in fact have a population of size 5, not a sample of size 5, I would be putting in that 5 here. It would be 80 divided by 5, and I believe that that is 16. 80 divided by 5. Yeah, that's 16. So my answer is B, 16.